Hi, Kelsey. How are you doing?
I'm doing fantastic and happy to be here.
Oh, let's see. After the first question, what was your first computer?
Oh, my personal first computer I got when I was about 16. It was an HP laptop that I bought from a friend,
Okay.
and I used it to play Age of Empires.
Aha. Okay. You are well prepared actually to this podcast. Okay. And and you kept playing, or you started programming, or what was the transition?
You know what? I didn't start programming or even had an idea of what programming was until probably the 11th grade. And in
Hmm.
the 11th grade, I was in a technology program for teenagers in high school.
Hmm.
And one of the classes we had was programming our calculators using TI Basic,
Okay.
right? And so my first program that I ever wrote was probably copying and pasting or typing in manually, trying to make a Pac-Man or Snake game on my calculator. And my
Okay.
professional programming didn't start way later.
Question about Pac-Man, because if you already knew Age of Empire, by the way, it was also one of the first games I knew on Windows, actually, Age of Empire. It was a strategy game with nice graphics, actually, and it was really addictive, I would say. It was a really interesting game. So if you knew Age of Empire, why you wanted to recreate Pac-Man? I mean, because Pac-Man, it was like, 10 years earlier. You knew Pac-Man back then? Or was it Age of Empire your first game?
Oh, no. I played Nintendo. I played Atari, right? In 1996, I was 15, 16 years old. And for me, that was just like a game that I just like real-time strategy games. The
Okay.
reason why I chose Pac-Man because that was the source code that was available to me, right? So you're
Okay.
looking at some existing code and you're basically just kind of copying and pasting the instructions and just hitting save to see what happens, right? And then maybe you tweak it a little bit. So as like most people, you're just copying and pasting. So that's what was available. That's what I did.
You are an interesting guest because what usually happens is, for instance, I started with ZX Spectrum, which was a computer and game console, in one machine. And this would usually happen. Most people are starting with C64 or whatever. But in your case, you started with a real console like Nintendo or PlayStation, whatever, right? And the PC happened later. So my question was actually wrong. It should be, what was your first computing device or something like this? Or what was your first console, right? Then you will answer
My
Nintendo.
first console was probably an Atari. Someone was going door to door selling their used Atari and Nintendo games or Atari games, and we bought that and we played it. And then the following Christmas, we got a Nintendo NES original
Okay.
with Mario and of course track and field with the power pad.
Okay. And what was your reaction? Were you delighted about Nintendo, or was it like, I don't know?
Oh, you know what? Coming from Atari,
Yeah.
Nintendo seemed like it was so real, right? It's
Yeah.
like, oh my God, look at the graphics. It almost feels like it's real. And it was only 8-bit, but it was
Yeah.
very interactive. You could interact with the world. You had a really clean 2D, the audio, the music. Yeah, so I just thought it was really cool, especially when I play a game like Metroid on the NES.
Yeah, I
Right?
remember.
That open world concept. It felt like you could go anywhere. You would pause the game because you would write down like the passcode so you can resume where you left off. And I just thought like, oh my God, there's no way that they can make a game like this.
Interesting. So, okay, this was your first, contact with computer-like device, and then the HP happened, and then you started to create Pac-Man. So, but why? I mean, you could just, keep playing Age of Empire, whatever was available to you. Why you got the idea that you would like to create something Pac-Man or a game on with Basic, which was hard, I assume.
Well, it wasn't that I had the idea, it was a class, right? So the
okay.
saying goes, you're a product of your environment. So my environment before then was playing sports. I played basketball, I played football, I ran track. Those were my interests. I was
How
only
good
doing.
were you in basketball and football?
I was
were
pretty
you...
good. I played quarterback and cornerback in high school.
Okay.
I was a starter. I was pretty good. I never was very tall. So being 5'9", there's only so far you can go. So even though my last name is Hightower, I'm only 5'9". And
Okay.
in sports, it helps to be tall.
Okay, but
And
Spud
so,
Webb was not that tall. You know Spud Webb?
yeah. So you could do it, but the odds are against you, right? It's hard to make it professionally, even if you're tall.
Yeah.
You can possibly do it, but the odds are against you. So being in a computer programming class or a technology class where one of the modules, right, there was AutoCAD, there was debate, there was building bridges using simulation tools, and then there was also this small piece where you got to do a bit of programming. And the device that we all had access to was our calculators, our TI 81. And so you use whatever TI basic program you could find, you would type that in just to get your first taste of what it's like to create your own program.
Okay. And, this is what I understood. Because I thought, you have to do something boring. And you said, okay, why not recreate Pac-Man? This was my idea. But the actual assignment was Pac-Man. This was actually great.
Well, you know what? In that class, there was no assignment. It's just you're sitting around and you're like, did you know you can program your calculator? Really? What's TI basic, right? And so, you could do little things like print something to the screen, but that's not very useful. And then someone shows up and says, hey, here's the source code to Pac-Man. Here's the source code to Snake. And you're like, oh, I've played that game on my calculator before. Now I can type in the same commands or the same syntax. And maybe if I type everything correctly, I can say I put the ingredients together. So for a lot of people, especially like me, it's the same feeling you get when you bake a cake for the first time. Of course, all you're doing is following the recipe, but nonetheless, you created the cake. And so you kind of know what goes into it. And then that gives you the courage to start writing your own programs.
Did it work in your case, the Pac-Man?
Probably some errors, probably a few trial and errors going back and forth to see what I got wrong. But it didn't necessarily make me want to program. I didn't probably write programs until 8 years later when I found it necessity for my actual job. Okay.
What happened 8 years later? Or what was the transition between, Pac-Man on BASIC and 8 years later?
A lot happened.
Okay.
When I graduated high school, I realized college wasn't for me. Even in a state where college was roughly free for a public university. I grew up in Georgia. And so if you graduated with a B average or above, you could go to any school, public school, that you could get into, and then your tuition was covered. And after going to a few classes, I decided this isn't for me. So I opened a computer store in my local city, which is like 20 minutes south of Atlanta.
Okay.
And I would help people fix PCs. I would take on consulting jobs for companies that wanted me to run a Cat5 cable. And so in those cases, it was more like build PCs, set up the network, install and configure some programs. And then when I got a job for the first time, I worked in a Google data center as a contractor, mounting and racking PCs and automating them with the automation tools that Google had at the time. And maybe a few jobs later, I understood that system administration only got you so far. It was the people that could actually write scripts or automate those tasks. And I would consider Bash a programming language in my book. And it was the first time that I really started writing code in order to complete some task.
Actually, Bash is a programming language, right? You can have nice functions. You can write if else. It looks a little bit strange for me still, but if I spend a little bit more time, it's actually a great automation. I don't know whether it's great, but this is an automation language.
I mean, there's always been a debate between scripting languages and general purpose programming languages, right? So in the scripting world, a lot of times we're just calling out to other programs, other binaries, feeding it data, getting data back, parsing it, and chaining things together. So when I was learning, a lot of the Java people, a lot of the Python people were like, oh, that's a scripting language. That isn't a real programming language. And so there's always been this little bit of tension around scripting versus application developers. But even with all the experience I have now, 20 years later, I definitely consider Bash a programming language, and it has its own semantics and its own model.
Yeah, and not as bad. So you get a function. So if you look at a Bash function, it looks like a proper function, right? I mean, yeah. What's funny, what I remember at the beginning, I'm a Java developer, JavaScript. If you told someone JavaScript, you were out. It's like, you are crazy. You are not a developer. You're doing JavaScript, right? So JavaScript, Visual Basic, this was not a proper programming language. I remember back then. Interesting. So you worked for for Google data centers. Also interesting, actually, to see it inside, right? So it was interesting job, I would say. At least at the first days, I think.
Well,
Hard
when
job.
that's your first experience in a data center, you tend to think all data centers look that way. And that is not the case, right?
Yeah.
Because Google data centers are well architected, well designed. They're hyper optimized for all kind of things, heating and cooling, custom hardware. These are the things you don't necessarily see in the real world. So when I got a chance to work in web hosting and walking into those data centers, definitely not the same, right?
Yeah.
In those data centers, you're just getting off the shelf components. You're managing those for people. There's not a lot of automation tools at scale.
Yeah.
And so there's a huge difference between a Google data center back then and the typical data center people have built with off-the-shelf products.
Yeah. Rika, I had a discussion with a client the other day about cloud security and own data centers. Okay, I don't think, there is a small company can actually compete with Google, AWS, or Microsoft, because, the data centers, they are running. They are really, on different level. So if you have a small, local data center, this is like a set of computers as stock machines, in a rack. This is not comparable what the other are doing with own power supply, airflow and whatever. You cannot imagine how optimized the system actually is. So what interests me, you said, college was not for me. Was it boring or too theoretical, or why you didn't like it? So why you prefer to run your own shop?
Well, I mean, for me at the time, some of the introductory classes, and it probably had a lot to do with the school I went to, right? Every school is different. Every curriculum is different.
Sure.
And so a lot of the introductory classes, it felt a lot like high school, the core classes that you take your first couple of years. And then the stuff that was related to computers, at that time, it's 1999 at this point. And a lot of the classes are basically teaching people how to use Microsoft Office,
Okay.
how to use a spreadsheet.
Okay.
And I think they wanted people to have some very elementary fundamentals. And of course, maybe the next semester you could go take Intro to C, Intro to Computer Science. But even looking at those classes, I didn't necessarily care so much about the theory. I was more interested in what can you do with the skill.
Yeah.
Right. And so that's why it just didn't appeal to me at the time.
Sounds almost like, beginning of serverless. A little bit Word, a little bit Excel and gluing things together. Just kidding.
Yeah, I mean, I like to see output. So I think there's a lot of value in those skills. So I'm not saying, hey, college is for no one.
Just fun.
Just for me.
Yeah. Yeah, that's actually cool. So so you work for a data center. I think these are pretty cold there, right? I can imagine.
Oh, yeah. I mean, well, at Google data centers, there's a hot side on purpose. And so they did that for efficiency. Instead of trying to keep everything super cool, you would just be very purposeful about where the heat goes, right? And so there's always a hot aisle. So it could be quite warm depending on where you're standing in the data center. But yes, in general, it's going to be cold.
Yeah. Okay. So you work there, and then you notice, okay, I would like to automate things. So you started with Bash. I think you didn't stop with Bash. So what was your next idea? So what is the transition between Bash programming and something else?
Yeah, I was at a financial institution, and maybe even before that in web hosting, but I would say it's that financial institution that really helped me understand the limitations of Bash. I was part of a team that was managing batch jobs as part of the overall work that we were doing. And, batch jobs, big files come in, they need to be parsed, and then they eventually get computed, and then data ends up in a database somewhere. And a lot of that work was written in COBOL.
Okay.
And so you look at that, and it's like, hey, you're walking these files, you're parsing the bytes, and you're using this programming language, COBOL, to do the work, the heavy lifting. And the team wanted to modernize. Now, this is a Java shop, so all the other stuff, aka modern stuff at this time, this is around, 2006, 2007, everyone wants to write everything in Java, but Java is very heavy, right? So just to make something that parses a file and having to do that for everything that comes in, people ask, is there a lighter weight way of approaching this? And so we did a lot that we could with Bash. You can only take sed and awk so far. And then Python became the thing which was my go-to. So writing a few libraries for packdecimal and epsidic, some of the stuff that was native to the COBOL world. And I just got really in bed with the Python way of thinking about things. So we started rewriting a lot of the COBOL stuff into Python. And it was really great because it had tools to parse files. It was easy to write. It felt natural coming from Bash, just to kind of focus on the task at hand. No types, really simple to deploy and manage. So that was the first language that I think I got really deep into. And then came Ruby.
Question. So you knew Java, right?
I learned Java just enough after learning Python because I was still doing system administration work. And then we started to take on these batch processing jobs. But on the Java side, we just needed them to do certain things. Number one, we wanted better error handling and better logging logic. We also wanted them to integrate with some of the infrastructure stuff, and no one had time to do it. So I learned Java at that time just so I could write that kind of code in the app stack.
You know which version Java was back then? This was Java
I don't know what
5,
I don't know what version of Java. I don't remember, but I do remember we were running a lot of JBoss, and this is before they went to the micro, segmentations of making JBoss smaller. So lots of JBoss, lots of Spring framework, lots of
XML.
Java. Yep. Oh,
You love
tons of XML.
right?
I don't love XML at all. I don't wish it on anybody.
I remember back then there was more XML than Spring actually. So it was a project where the XML configuration was longer than Java code. It's like you're all crazy. Okay, interesting. So what's interesting, I started actually with Java, and then came Python. And people ask, look at Python, and I look at Python, and I really didn't like that because what really the formatting. I think this is just crazy. I don't like it, and it's interesting. Ruby looks nicer, but Python for me it was ugly and somehow hacky. So I preferred Bash actually more than Python. So it was interesting for you that you liked Python from the beginning, or was it like the necessary evil?
Yeah, it's more necessary evil because it was more about the ecosystem, the libraries, the framework. There was good documentation, books. There was just such a huge community around it. I mean, I started going to local meetups and just watching people give talks about the tech, and then also myself getting involved. And there's also an open source angle because what I found is that when I had problems in the Python ecosystem, I could just contribute to make it better. So for me, I was really drawn equally to the community as I was to the ability just to get stuff done.
You thought you can contribute something meaningful? So was it because for me, Java was also big in open source, but if I look at the source code, I say the others are really no smart. This is no way that I can contribute anything, which is really
you have to define meaningful, right? Because meaningful to me is, for example, I was using package managers, PyPy, virtual inf, and they would have errors. And so when there was an issue, I would fix the issue and then submit the change upstream.
Okay.
Mainly just to fix my own problem.
Yeah.
And once I started contributing to these things, the maintainers are like, hey, this is wonderful. I appreciate these contributions. That turned into, look at these new features that are waiting to be implemented. Let me grab some of those as well. And so eventually I started spending a lot of time working on, there was a project to start pushing virtual env and disutils into the core Python, so you didn't have to add them later. And so PyEnv, those are tools that I was working on at that time because we were trying to solve this problem of discovery. There were so many different ways of packaging Python modules that the team wanted to take the best of all the worlds and move them together. So scratching my own itch turned into feature development for the rest of the community.
And you became a committer, Python committer, or?
I don't know if you call it a committer. I was mainly working on virtual env and PyPy stuff. So, I guess I wasn't thinking back then. It's more of it. I had probably commit access. I could merge things. I could review code for other people. And so, I'd probably say you're at the point now where people trust you to review and merge things.
And did it happen in your leisure, or was it like your job of contributing?
Leisure. When you're working in financial services, number one, they're scared of open source at that time.
Yeah.
And number two, people wouldn't really understand why you were working on free software doing company hours. And so it was one of those things that I had to do in the evenings. But the funny thing is, once the code got merged, it became something that we would use in our own environment. But at that time, that was really the only way to get permission to actually contribute to open source. Okay,
but I mean, you have enough time to do this? Because, my time back then, I don't know, 2006, 2007 was just crazy. I had I worked 12 hours in normal projects, so the evenings to contribute something. So it was tough, right?
Yeah, but you got to remember at that time, I'm also maybe at year 6 of my kind of working career.
Okay.
And I understood the value of getting new skills and how much money I would make when I did it. You know, there was times where I would double my salary between one job or another. So working in the evening to me, and remember, I'm coming from a world of athletes or athletics. And so in that world, you have to practice outside of practice. If you only practice during the 1 hour you get after school and then hopefully you're ready by game time, you're not going to be any good.
Yeah.
And so to me, the open source work is more of an investment too in my own skill set above and beyond what the company was going to require.
Yeah, so actually a wrong trajectory. You could become an influencer on YouTube, you know, and sell shoes or whatever. And then you can just, you know, train one hour a week and then, you know, show some sport shoes and you'll become, you know, famous person.
Well, I'm going to defend the YouTubers for a moment. The reason why I think those people are important, because like you said, you're too busy. The people who know what they're doing with a lot of this stuff, they're too busy. They're too busy doing all these other things. So who teaches the next generation?
Yeah.
Who helps that person that is just brand new? And so we need that. And so YouTube is a very popular place where people go to learn new stuff. Even me, right? There are some things I just don't have time to go figure out from scratch. A good video goes a long way. So, and also back then, there was no YouTube like it was now. I mean, YouTube existed, but there really wasn't this idea that you could actually become a creator full time. So I don't know if people knew to leverage it that way.
Yeah, very good. So it was meant as a joke, right? So nothing serious. Okay. Okay. So what happened then? So you spent some time, you know, in the financial institution. You learned Python, so you became, I would say, pretty good with Python. So if you could contribute, so were you the Pythonista, or were you already, you know, were you able to write Pythonic code? So you got, you know, the idea what is, you know, a nice Python way to write. Yeah.
Yeah, actually, that's the one thing I think I did appreciate about the Python community. They had their own style guide. Yes, it was awkward. Tabs and spaces can dictate how the app actually runs. But you submerge in that culture and you learn why it's the way it is. Also learned where things like list comprehensions came from. So then you would go study Haskell to kind of see the take that Haskell had on functional programming. And so it kind of opened my eyes just beyond the tech as a tool, but tech as an engineering culture and philosophy. And so, yeah, I bought into all of that. And when it was time to transition, again, I started using Puppet for configuration management, right? And Puppet is written in Ruby. And Ruby has its own culture and its own style, right? You read the stuff from Matt, you know, he's like, hey, Ruby should be beautiful, right? You're almost kind of speaking to the compiler. And so I embraced that style by reading the Pickaxe book. I don't know if you remember, there's like the Ruby book, it was like the one. And, you know, I got into things like design patterns and object-oriented programming and, you know, trying to make beautiful code, something that people would appreciate when they read it. And so, yeah, I think that's where I have a deep appreciation for Python, because it helped me understand that when you go into a new language community, you should take the time to appreciate their style and the culture that they brought to the table.
If you know now both worlds, so how you would compare, you know, a nice Ruby program and nice Python program? What's the difference? Can you if you would?
Yeah, I would say, honestly, to me, it just doesn't even matter. Like when I got into Go, the Go programming language that doesn't have any of those features that you find in Ruby, I felt like I can focus on writing the code and not making it beautiful. I can focus on the task and not meta programming or trying to reverse engineer some weird design pattern, because the Ruby language allows you to do that. And so when I looked at Ruby, there was a lot more magic in my experience. I used to work on Puppet, and Puppet had a lot of indirection. It had a lot of injection and overriding. And so I think the Ruby community, out of convenience to give developers that kind of clean API, also you could just call like, you know, .json, right? The meta programming required to do that, right? You start intercepting calls. And to me, while it looked great on the page, the mental gymnastics I had to do to maintain that kind of code or understand what the hell was doing, I found that way too complex. Python to me, I think over time, I think I started to get annoyed with the tabs. because it felt like it was unnecessary mental chore that I had to do. But other than that, they all have if statements. They all have a way to model the world via encapsulation. And so to me, I just thought about it all now as just syntactic sugar. And the thing I liked about Ruby, the focus on frameworks, like Ruby on Rails, Sinatra.
Active record, right? The patterns you mentioned, maybe.
Yeah, so I did like that component. So to me, I just grown to respect the language ecosystem. So if I'm doing data, I probably lean towards Python. If I'm doing a web app now, like a real web app that needs MVC patterns, maybe Ruby on Rails is still a good idea. But Golang is kind of my default for some of the back-end automation tools that I'm writing these days.
Okay, interesting. So it's also my impression that Ruby is more like, you spend more time thinking about DSLs and meta programming that looks nice, almost like language, which you will speak, and for users. And Python is more pragmatic, where, you just focus on the functions and you just, more functional, I would say, and Ruby more DSL-like. This is my impression.
I say that both of those languages support the things you spoke about, right? So you can just write Ruby like we used to write Perl, just make it work, shell out to the command line if you need it, and then you just had a better way of dealing with objects. Okay, you could use Ruby in a very simple way. But you're right. When you start to see until or while, you start to ask yourself, I got all of these choices, and I'm going to use the one that represents how a human would read it better. And I think that's where you start finding yourself spending unnecessary time deciding, should I do while or until? And I think that's the thing that throws people off.
This is interesting because in Java, so my main experience, right? So maybe the years you spent, 2006 and 2007. So my observation was most of the project were like crazy. So they implemented an interface, have an interface, right? The interface was implemented by exactly one class with the name impl. It's like, if you think about this, if you name, the class impl, there's no way that someone can introduce another class with how you call it, impl 2 or 3 or what's the name, right? This is already ridiculous. And then they say, okay, now to be really flexible, we specify in the XML how everything ties together. So, the class was loaded at runtime. And I was in projects and thought, look, we have now, 5 years experience. Just take a look at Git or whatever, a Subversion back then, in the history. There was not even one use case where we replaced the implementation. It was always that way. So, and what's interesting right now, all Java projects look completely different. I'm in large Java projects without a single interface, just Java class, and no one cares, because if you write simple code, you can very easily maintain it later, replace it, no magic, no patterns, nothing. What you are saying about Ruby and Python, the same happens in Java. And now we can talk about it, but even 2 years earlier, so people say, oh, you're writing a monolithic code or whatever. It's like, yeah, but who cares? If it's simple, everyone understands it. I would say the mastery is to write really that simple code, right? In whatever language you have. And it just, a little patterns if you really have to do something really complex. But we spend a lot of time now, I would say, in semi-complex projects, and we still don't need, a lot of patterns.
No, 100%. I think the thing that turned me off about Java in the early days was, in Python, if I want to open a file and read some bytes, that's what I do. I open a file. I now have a stream of bytes, and I can parse them. I can do something. Then I can close the file and exit the program. But you're right. In the Java community, it's like, no. There should be a file type, an implementation. The file could be coming from a stream. It could come from a file. I was like, I don't know, man. I just need to read a file at this path. And I think that's when I was introduced to like what they call plain old Java, where people just say, just write simple Java, use it as is, and don't overthink it. Yeah.
Now in Java, you have files.read all bytes and you're done. So this is one word. It's shorter than Python. So Kelsey, we need you in Java. Come back. So you will really appreciate it.
No, I've seen some new stuff with the Java world, and I'm glad that they have converged around everything doesn't need all of that ceremony. And maybe just one day people can actually write Java using something like Vim and not a full-blown IDE.
Yeah, I use Visual Studio Code all the time, for instance. So it works perfectly. Very cool. So you did the chef automation. What happened then? In one point of time, you started at Google, I think, right?
There's a lot of jumps in between. So I was at Puppet for a couple of years, and there I was
What was your role at Puppet?
at Puppet, I was a developer. So I came from this blended role of doing development and operations. And then when I came to Puppet, remember when I was in a financial services company, I was contributing to open source Puppet. So adding new features, fixing bugs, and getting to know a lot of the people who were working on the core of Puppet. And so as an open source contributor, when I gave a talk at PuppetConf for the first time, I was kind of talking about a new feature that I was also contributing to. And so when I interviewed with the team, I kind of knew a lot of those people already. So when I joined Puppet, I joined as a developer who happened to have a really good ops background. And so I worked on some of the new features like building a package manager for Puppet so we can have native module integrations, kind of like Ruby gems, but specifically for Puppet code. And just building other things like that. And so there was this time where it was all about Ruby, extending the Puppet ecosystem, and also learning a lot about the performance drawbacks of Ruby, right? Having these kind of global locks, you really can't do a lot of things. So we actually started to move a lot of stuff to running Ruby stuff on top of the JVM. That got us only so far, but then Go came out. Containers came out. And so that's when I really mentally started shifting towards, can we rewrite some parts of Puppet in Go? No one was really on board with that. So I actually left Puppet and went to a smaller company where I was a director, VP of engineering. And there we were able to just start adopting some of these new tools. And also I continued my open source contributions, but this time to the Go community.
Okay. And what you did at the company with the
so after Puppet, I go to this small company called Monsoon Commerce right outside of Portland, not too far from the Puppet office. And that team was really running like these back-end services for their pricing engine. So if you're selling things like books and you want to sell it in the Amazon marketplace, you could use their software to, number one, get your inventory into the Amazon catalog. And number two, do real-time pricing. In order to do that, we had a lot of back-end services that were written in Python, a lot of Java, and just starting to experiment with things like Node.js. But the biggest problem we had there, though, was the Amazon build to support all of that. I mean, we had hundreds and hundreds of instances, largely due to unoptimized Java. I don't want to blame it on the JVM. But when you don't optimize it and you're using big, heavy frameworks just for basic REST API calls and just pulling data from like Amazon APIs and storing somewhere else, you can do that way more efficiently. And so that's where I introduced Golang and also started to contribute a lot more to the Go ecosystem. Tools like Terraform, even open source my own project called ConfD, which was written in Go. And it was a replacement for Puppet because I didn't think we needed a full-blown configuration management system. We just needed a small bit of config management. So I built a tool to help us do that.
What's the name of the tool again?
It's called ConfD. It's still online. It became pretty popular. You know, when you think about configuration management, it does all of these things. You put an agent on the server, and it tries to manage installing packages and all these other things. And coming from the Ruby community, it was very interesting because in the Ruby community, we tend to separate the tools. We use things like config management for like config files, database connections, you name it. But then for orchestration, we use tools like Capistrano back then. And those were just much better at application lifecycle management than config management tools were. And so when I went to the new company, I was like, look, we're just installing stuff on a bunch of VMs. We can actually do that in a much easier way. So the only thing that's left is we need a way to manage the configuration files. We don't need all the other stuff. And so I wrote ConfD to be able to give you the ability just to focus on the application configuration and leave installation to another tool.
So what you did is it just generated on the fly the configuration, right? Depending, like a template language for, like a Helm chart, something like that?
Yeah, so something very similar. So back then I was using the Go templating modules to allow you to kind of express, and this is very similar to what we used to do in the Ruby world with ERB templates when I was working at Puppet. That was the foundation for the Puppet file resource. So I used the Go templating language, and then I introduced a bunch of the helper functions, right? So Go really lets you introduce custom functions. And so ConfD became a thing that could watch different backends like etcd or some other key value store. And then I used TOML as the configuration language. So you as a developer would say, I need these files. Those files would map to templates, and I care about these key value pairs. So at runtime, I could run just once. So if you're just doing something one shot, or I can just run in daemon mode where I would watch those key value stores, batch up the key value pairs, and then regenerate the templates and the files, put them in the right place, the right permissions, and then restart the application if necessary. So it was just a little bit of functionality you needed to get you the configuration management stuff that you were getting from those other tools.
Yeah, I did, even with Java, something very basic is env-subst, I think, right? This is like, you know it, so you can just replace, env-subst is just a command in shell, I think, env-subst. And what it just does, you can substitute, a placeholder with environment entry. So very simplistic way for it's just that, it's nothing else, And so what it seems like in that company, you run EC2 virtual machines, right? EC2 machines. And this is why
back then the deployment model was basically using a bunch of EC2 instances.
Yeah.
Under auto-scaling groups attached to a load balancer. So for each of our services, they were just small pools of EC2 VMs, right? So Docker had just come out, and we were kind of exploring it. But at that time, it was just easier just to use Terraform, create your instance groups, put it behind a load balancer, and you just had little islands of services.
Funny, because you say, you introduce Go to save money. And I submitted a talk somewhere, how to save money with Java in the cloud, but with serverless mode, because interesting, if you build lambdas or functions, for instance, and Java program runs all the time, becomes faster and faster. And usually in all cloud environments, you have to buy CPU with memory. So memory is less an issue. And if you need one core, you get a lot of memory. And then it runs pretty good. So, but back then, if you're running on EC2 machines, it's completely different because, even a little bit larger EC2 machine costs you a lot of money. So you have this is a completely different story. So it's interesting how what I tell in cloud is actually, I call it, cost-driven architectures. In cloud, really doesn't matter how nice your architecture is, your modules, whatever. It should be cheap. Otherwise, it will die. Right. So, and this is also, profiling in the cloud. We are not profiling, our CPUs. We're profiling the bill. So you get the invoice. We look at the invoice and say, hey, look, this is too expensive. Now we have to optimize this. And this changes completely the conversation, all the esoteric conversations, decoupling, loose coupling, whatever. No one cares.
No, I think that's how it should have always been. But, my time in the enterprise, you just had access to these large servers.
Exactly.
All by yourself. So it was no problem if you just 64 core box and it's just one app with a bunch of threads running. No one thought about it until there became a cost premium for doing that.
Yeah. And it was actually before you mentioned AppStick and host. On the host systems, they were actually able to see how much, CPU cycles a query really takes. And they always know the old, host guys told me always, you with the Java stuff, no one knows what you are consuming. And we can tell exactly, how well our system is running. And now, funny enough, now in the cloud, we have almost the same what host did, 30 years ago. So it's interesting. We can always learn, from the past. And okay, cool stuff you did with Go. And you like Go from the beginning? I mean, I can imagine, if you are a Pythonista and then how it's called Rubyist, and Rubytonic, a Ruby fanboy, and then Go happened. It was like a shock, no?
Yeah, but I think it matches my maturity curve, right? First, You're really excited about the language, you're excited about the community. Look at all these cool patterns, look at all this cool stuff you can do. But after a while, I just need to write the software. Okay. And ideally, I want to do it by writing as little code as possible.
Okay.
I think there was a point in time, too, where I was just really fascinated with just learning C, learning a little bit of assembly, just so I can understand it, understand what was happening behind the scenes. And the thing I liked about C, not the memory management, but how simple it looked, right? You just write simple code. Most of it looked very procedural. So easy things felt like it was easy to do, especially if you understood how to make syscalls and interact with the various libraries. But when Go came around, it felt like C, right? If this, do that thing, and just write your code in a procedural way. And then the ability to have things like channels. And, if you're going to write a type, just a simple struct, it reminded me of the simplicity of C, but it had a lot of the safety properties that I was getting from the dynamic languages. and it wasn't as noisy as Java was, right? If you just wanted to, instantiate a variable, you didn't have to mention its type. Go would do type inference for you. So at that point, I was just like, great, I can now write code like I used to write when I was doing just Bash. Keep it very simple. But then it turned out it was fast. I can do cross compiles. I can target Windows by writing from my Mac, a single binary. So it made the deployment process much easier. I wasn't worried about what version of Python or Ruby is on the other side. I had to have all these gem dependency files that I would have to ship around. That was gone. Everything was in that Go binary. I can trust that it was going to actually work. And then the benefits of having the threading model just be a part of the standard library. So you import the HTTP server, and as a request comes in, your code looks very procedural, right? You just write a function, you register that function with a handler, and then behind the scenes, it's doing all the concurrency things that were very hard in the other languages, or damn near impossible because they had global lock interpreters where you can only do one thing at a time, and then you had to do all this multi-processing stuff. So when I looked at Go, I was just like, this is everything I need to build backend services, APIs, and command line tools.
Exactly. I had chats with Go developers, and they told me that Go is really good for CLI. Why? Why it is so good for CLI? What makes Go a perfect language to build CLI tools?
Well, I think the context of a CLI tool, typically you're not doing multiple things at a time, typically, right? Sometimes you may do a backend call to a remote API and you have to wait for the results. But the interaction that a normal person has with a command line tool, you tend to start up fast. It needs to be very easy to install, right? And if it's very easy to install and it's fast, in the UX, the initial experience is like, just go get this binary and run it. You've already beat that part. The second piece is when you look at like function main, right? You just do function main, print, log.printf. I'm starting the command. You need very simple flags. Import the flag package out of the standard library. Parse a few flags. And then just write code like you normally would. If you do need to call out to another command, the os.exec package, pretty straightforward. You exec a command, comes back. You can open up a stream. You can just call wait. And then all your code looks very procedural.
Okay.
But you also have a very powerful language for serialization. So the JSON is built into the language by default. So it just feels like you can stick with the standard library and build very powerful command line tools.
This is cool because in Java we don't have it. So there's an external, we use JSONB, but there's an external jar. Having this in the language is cool. But actually, you remember Scala?
Yep.
So what I remember is Java was supposed to die because Scala introduced XML support in Scala. And everyone said, okay, why Java doesn't do this? And I would say it was a very good idea not to do this in Java. So this could be also a problem, right? Because if, let's say, TOML or whatever becomes more popular, then Go gets trouble with the JSON support, right?
Well, the good thing is, though, is one thing that I liked about the Go standard library, they had interfaces for everything. So first they would have an encoding interface, right? So whatever the encoding was, you would just have an encoder and a decoder. Those very simple interface. And in the standard library, there's JSON, there's XML, and there's other encodings for doing things like TLS and those various encodings. So those came out of the box. But let's say you wanted to add your own encoder. Well, it was really easy. You would just build your own encoder and then implement the interface, and you didn't have to do such tight coupling. You can just implement the methods. You had to make no reference to the actual thing on the other side. And so then when people would import your library, they can just call encode and decode, and now you got support for new...
Almost Java interface, right?
Yeah, but it's so loosely defined. For example, let's say I'm unaware of the implementation. I don't even have to import it. I can just say, on my strut, just implement the two methods, and I'm done.
Yeah. You're right, this would be not a problem, because Go could, ship a new version with a default encoder for whatever. This is more interesting, because in Java, we, of course, can do, whatever but having an external library... always a little bit suspicious. Okay, you have to maintain it and version it, and this is always a problem. So I try to avoid any external dependencies. And if something ships with the language, is great. If something is external, I'm a little bit suspicious.
Well, one thing I think the Go team did really well was make it very easy for even third parties to feel very first class, right? The module system in Go, typically, most people are just using GitHub and tags on Git repos. So Git is a native part of the Go kind of build system, so it knows how to fetch these dependencies. We also have what we call the X repository.
Are you now Go evangelist, by the way?
No.
No? Okay, very good, because this is really, honest opinions are cool. If you
I mean, I'll use the right language when the time comes. I think for me, though, like choosing it in the ecosystem was because everything felt first. It felt like we learned a lot from all the other languages.
Yeah.
It wasn't like Go just thought of all this stuff themselves, right? People who worked on it worked on the hotspot compiler. They worked on all these other things, Smalltalk and the previous languages that came before. It just felt like Go was embracing the modern world. We need a big standard library. We should have things like concurrency built in by default, cross-compiling. Oh my God, it's just built into the tooling.
Yeah.
And so I think a lot of those things is what we were all hoping that a new language would bring to the table.
Okay. So you saved a lot of money for the company just replacing Java with Go, right?
Oh, yeah. And we reduced a lot of instance sizes. And also the team, the number of people who can now write backend services increased. You didn't have to think about learning all of Java. I think it took some people on my team a couple of weeks. I mean, first they looked at the Go syntax and like, is this it? Where's the classes? Where's the inheritance? Where's all this other stuff? Like, there is none. Just write what seems like it's procedural code. So you just got to embrace it. And then the number of people who could do that, even the people coming from .NET were able to start to write Go code for the backend APIs and then switch back to .NET for their other development.
Kelsey, I will cut this part out, It should be not to, because I'm Java fanboy. Just kidding. Very cool. What happened after this?
So the nice thing is, once I had all that time in production with Go and some of the new things, after having that open source project, I was also committing to tools like Packr and Terraform.
Okay.
Right. HashiCorp also was born in the world of Go. So Mitchell Hashimoto, he wrote Vagrant in Ruby. So lots of infrastructure tools were written in Ruby back then. But then Go started to take over. So Docker is written in Go, Terraform, Packr, various tools from HashiCorp are written in Go. So I'm all in at this point. And my next job ended up being at CoreOS. And so coming to CoreOS, everything was about containers. They had their own Linux distribution that was focused on containers. They built tools like etcd. And so at that point, I really started to understand a lot of the theory of computer science. So before, being an system administrator, you kind of break things, you fix things that are broken. And then use tools to automate things that you know how to do. Then working at a product company like Puppet Labs, I understand feature development and customer feedback and building enterprise products that you sell to people. Going to that smaller company, remembering how to leverage all of that stuff in production is very different than just building new stuff, selling it to people. Using in production is a whole different thing. So coming to CoreOS is like, hey, we want to implement RAFT, right? So there's a new white paper to talk about consensus protocols and something simpler, more simple than Paxos, something that you found in some of the old distributed systems. And so here's CoreOS on the cutting edge. They're going to have an operating system, a Linux distribution that's focused only on running containers. Everything else is going to be read-only, no support for Puppet, Chef, or Ansible, just containers. So Docker is installed by default. And we're going to realize that the world is clustered now. We're not just going to do a single machine. We need an easy way to distribute configuration across multiple nodes. And remember, I had just built an open source project called ConfD, and it was built with etcd as a backend. And so I was thinking about this world as well. And so what they were doing is taking a lot of the Google stuff from white papers and giving people an implementation in the open source world. And so I became really interested in distributed systems, key value stores, operating systems. And there was a company that was 100% about making infrastructure that would leverage all those expertise. So I was at CoreOS for a very long time doing that kind of work. For a couple of years, it was all about understanding how RAFT works, how RAFT breaks, how to deal with these logs, why CAP or CAP theorem was important, and then how that world intersects with system administration as a whole.
But RAFT was mainly because of etcd, right?
Yeah, so I think the theory was if you want to build orchestration systems or anything that needs to coordinate, you have to manage states somewhere, ideally in a consistent manner if that's important. And you have a couple of choices. You can do it in every other system. So you can do it in your database, you can do it in your command line tools, you can do it in all those places. Or you could have a central place where configuration could be coordinated. So if you're going to build a new system, you can assume that etcd would be there and you can use that for coordination. So if you want to agree on a value for the database password, well, you can write that into etcd and know it's going to do all the right things in terms of replication, consistency, etc. And so, yes, RAFT was not just a way to synchronize and keep data consistent. RAFT also talked about cluster membership. And so if you're going to have a 3-node cluster, well, how do you know who is the leader, who's the follower? And how do you add and remove additional nodes into that cluster configuration? So I think that's what made RAFT very interesting. It accounted for the other things you had to do when dealing and replicating data.
And the story behind RAFT is also interesting because I think there was like someone who read Paxos, tried to understand and wrote another paper, which became RAFT, right? So the story itself is really, really interesting.
Yeah, I think it was a college student, he was doing his, I believe it's his PhD. And yeah, that story lines up. This guy, I think his last name may have been Diego. Maybe that's his first name. And Diego said, hey, he just wanted to write a consensus protocol that the average person could actually understand and implement. And so if you read the paper, I think there were holes in it. So the one nice thing that really made CoreOS attractive to me, they looked at the RAFT paper, they've implemented it, but then they found a lot of missing pieces when you're really dealing with production. For example, if you turn everything off, how do you come back on, right? You may not be able to ever have a quorum when there is no leader at all to actually do the leader election, because in the RAFT protocol, leader election is also done in the RAFT consensus. But what happens when there's no quorum to begin with? So you have to have a special bootstrapping step in order to elect a leader, and then you can get into the consensus mechanism for voting for a new leader in case the other one would fail. But they were finding all of these production level gaps, which led Diego to go rewrite or have an updated version of his RAFT paper that would account for some of these things.
Interesting to say that because you mentioned JBoss, and most of the application servers did supported protocol called XA, or distributed two-phase commit to PC, or XA, or distributed transactions. And some servers in production run without transaction log. It was exactly the same what it said. So the client forgot to set it up. So, and the server was the coordinator. If something broke and the server was shut down and it came up, forgot what he did, right? So all the resources, they were just they time out, and you could restart the server several times. It didn't got any better because it still didn't knew what to do. So actually the proper way to run application servers back then was, to have a transaction log, which is consistent, and the server shuts down and goes up, knows what to do. The problem, of course, was how to, distribute the log, because if another cluster node would like to come up, you will have, to ship the log there. So this is why we never used actually two-phase commit in proper systems, because it was not usable. And of course, there are lots of, corner cases as well. I don't know.
And that's why I think tools like Zookeeper were so important in the Java community, because Zookeeper would deal with all of those things.
Kafka still uses Zookeeper. They try to go
100%.
away, but Zookeeper is really old actually. If you and there is a new system. It's called I think Bookkeeper. It's a new from Apache. It is also in Java. It is used by Apache Pulsar, for instance. Interesting that I didn't knew that you also spent some time, with distributed transactions, and this is.
Well, I mean, look, as a contributor to Kubernetes, when I started contributing to Kubernetes, I was working at CoreOS, and we had our own orchestration system that was built on distributed principles.
Was it Mesos, or was it your own system?
No, we had our own. We called it Fleet. It was written in Go, and it actually leveraged systemd for the local management of binaries. And the idea would be you would give Fleet your container image, very similar API to kind of what you see in Kubernetes today. And then what Fleet would do, it would pull your container and then run it under systemd for local management. But then we would coordinate all of this state using etcd, which is already installed by default as part of the Linux distribution that we had. So when Kubernetes came out, I was so interested that I just started contributing in the early days, helping add things like adding and removing nodes. There's lots of little bugs. You also have to have your own cloud provider. So again, CoreOS was designed to run in the cloud or on-prem. And the way Kubernetes worked, it kind of assumed that it was already in the cloud. And so you had to write your own cloud provider. And so I started writing cloud provider integration so that CoreOS could run on-prem with things like Kubernetes. So that Kubernetes is really one of the best, I think, architected distributed systems for managing applications because of its monolithic nature and how clean the external API is.
What's interesting about CoreOS, what you mentioned with the systemd, this is actually a really interesting design that you are running systemd with modules which are Docker containers. Actually, the idea is pretty cool. So you could have actually one server, right? One server or one box with multiple containers managed by systemd.
Well, the funny thing is that's how it works still today. I think a lot of people got confused when Docker came out. When Docker came out, they had this wonderful user experience, right? Number one, they made it much easier to build applications. So if anyone comes from the Python or the Ruby world, it was a pain managing dependencies between different versions of Ruby or Python. Java was equally painful. I built a lot of tools to allow customers to have different class paths and different versions of Java. You can't mix those things and bad things will happen. So Docker gives people a much better way of building things. But at runtime, a lot of people didn't remember that the kernel is the only thing that can run the app. All Docker can do is get the file system prepped, the container image exploded, but it has to hand it off to the kernel to actually execute and allocate memory and do all of those things. But what Docker did, though, is it didn't use the local init system. And so instead of using initd or systemd, Docker was playing that role as well. The problem, though, is Docker did a lot of other things like logging, networking, downloading containers. And at the time, the way Go was managing system calls, you could find yourself in a lock where instead of babysitting the app, you would go and pull an image and then you would zombie the process. Now what? Now you're stuck. Right? And then if Docker crashed, it would take all its children with them. And now Docker's crashing because it's trying to pull an image and all of the processes stop. In a normal Linux system, that doesn't happen, right? You start a program and the init system takes over and your program is free to go do something else. And so I think now a lot of people at the time at CoreOS, we thought systemd would be a better approach. So we would do all the things Docker does. We had a container runtime called Rocket. And with Rocket, Rocket was RKT.
Exactly.
And
those the huge container wars, right, between Rocket and the Docker guys. Exactly.
Yeah, there was a little, and that was one of the biggest sticking points was, should Docker even attempt to be the init system? And we thought the answer was no. And so we decided to hand things off to systemd. Now, a long story short, what happens is, eventually we realized, and the Docker community agreed, now we have OCI, so we split the thing in pieces. You have run C, which is a little bit smarter about taking things and just doing one thing well. And then you have the other things for pulling images, for taking API calls. You have containerd for orchestrating and creating sandboxes for all of this to occur. And so I think the system is way more stable than it used to be.
My observation is what happened was Docker was crazy successful and Docker was a product and almost a standard because everyone just, this container and Docker was one thing. And then OCI or Run C is more like the product became standardized afterwards. So, and there were multiple implementations. And this is like what happens with Java as well, right? It started with Sun Java or Oracle Java, then we got OpenJDK, and now we have multiple Java. So this standardization happens afterwards. And now it's even hard because I always have to say, don't speak about Docker. We have to to talk about containers more because Docker is just a product and Rocket could be a product and whatever. So this is what happened back then. What interests me, why you started to look at Kubernetes, because I would say this CoreOS was really interesting already. So I mean, this is like you had a problem and you wanted to see a solution somewhere else because for me, I look at CoreOS was crazy interesting because in Java we had a system which was completely overused and a little bit, I would say, back then over-engineered. It's called OSGI. And these OSGI were small modules which you can load and unload. And if I look at CoreOS, it was the same on system level. So, okay, the Docker, you can, have module and you can make... I found this really interesting. And I always maintained my own server. And back then, I used Docker for strange purposes, not necessary to virtualize things, but to document things what I did. Because with Docker, you have nice Docker file. You exactly know what you did a few years ago, so you can repeat everything. And this was like a backup. But Docker was not very stable. What you see with the zombie processes, I had a huge problems at the beginning of Docker with the file system. It became corrupt, and I think it was Docker like 0.6 or whatever. And after that, it would become a little bit more stable. And I really look at CoreOS. It's like, this could be the solution. It would be really cool, to run CoreOS all the time. And so why you looked at Kubernetes back then?
So there's a couple of things too, just to kind of defend Docker a little bit. Docker was leveraging new APIs in the Linux kernel. Mm-hmm. And so like the mount namespace stuff and all of these things, they were also evolving. And I think mm-hmm. Docker usage really accelerated more people using those kernel features than before. Mm-hmm. And so, of course, using it this way, we put a lot of pressure on those systems and that help evolve. And so this is why we have a lot more stability mm-hmm. in the Linux container world now. The thing about Kubernetes, and the thing I learned as an engineer, there's always going to be competition. Mm-hmm. And you can ignore it and just keep working on your own thing, or you can understand what the competition is doing. Mm-hmm. And especially in the open source world. When I was at Puppet, there was Chef, there mm-hmm. was Ansible, there's all these other ones, Salt. Some of them were written in different programming languages. And I tried my best to use those and study those. And if I found something nice, you try to implement it. Mm-hmm. So when Kubernetes came out, I looked at it and said, wow, this looks like what we would build if we had the same experience as the Googlers who worked on this. Mm-hmm. And we didn't. Mm-hmm. And so you can copy the features. Mm-hmm. You can try to standardize the Kubernetes API and do your own implementation. Mm-hmm. And when we thought about it, Kubernetes was already using etcd. Mm-hmm. It already ran on top of Linux. Mm-hmm. So in some ways, we were already involved mm-hmm. indirectly. Mm-hmm. We also worked on a container thing. I actually wrote some code for CNI, the container networking interface, and we wanted something very simple. And guess what? Kubernetes also ended up using that. Mm-hmm. And so we were already kind of there. So when I was starting to play with it, I was like, wow. Mm-hmm. The thing that's different about Kubernetes and Fleet, what we had, Kubernetes API really addressed a bunch of concerns we were not thinking about. Mm-hmm. Like a real application is going to be composed of multiple container images. Kind of like, I remember even when I ran JBoss, sometimes we would put Nginx in front, even on the local server, to handle some of the things that JBoss didn't do well, mm-hmm. right? Or to like manage SSL certificates better mm-hmm. than going through that whole Java interface. That mm-hmm. was not fun dealing with the local SSL store. Yeah. So I always knew that a logical application was always made of multiple binaries. Mm-hmm. And so when you looked at the Kubernetes API, the concept of a pod, mm-hmm. so you can actually articulate, I need these binaries to go together, mm-hmm. and I also need these file system things to be together. Mm-hmm. Oh, and here's how my app does health checks, and these are the config files that I need. So when I saw how complete the API was, I was like, this is the right pattern. And the other thing that they did well that a lot of people underappreciate, when HTTP became super popular, right? There were lots of custom protocols, as you know. When HTTP got really popular, people started to build not just web pages, we started building RESTful APIs, mm-hmm. right? Like mm-hmm. put, post, get, delete. And the Kubernetes API looks very similar in terms of its utility outside of the core system. Mm-hmm. And so you have this way of describing infrastructure in a declarative way. Mm-hmm. And we've always had that in some ways with all the configuration management tools, but Kubernetes did something super unique. Number one, it coordinated state through etcd by default. Mm-hmm. Second, it had the status field. Mm-hmm. And that status field helped you understand that, yes, you have an instantiation of this object. Mm-hmm. But in most programming domains, it's hard to capture the actual state that it's in. Like in Puppet, you create a module that says, I want this database at this version. That's all you had. If you mm-hmm. wanted any other data, you would have to get it out of band and reconcile the two. Mm-hmm. Kubernetes combined those two pieces. So when you looked at the status field, mm-hmm. you knew if the container was waiting on a config file. Mm-hmm. So you can keep the declarative thing clean mm-hmm. and then put the arbitrary data into this status field. Mm-hmm. And so the type of systems we could build, we also enabled these extensions. So I just thought Kubernetes was going to be, its design was way better than ours would probably ever evolve into. And so I was hedging. Not that CoreOS is on board day one, but they're an open source company, so they didn't mind me contributing to open source. But I think there was a part of, eventually I did start to talk about it in public, doing keynotes and meetups, because I was so excited to show the things that I was working on. And then eventually we kind of felt it. This is CoreOS plus Kubernetes is better than CoreOS alone. And so we became a Kubernetes company.
And then CoreOS was bought by Red Hat, I think, right?
They got bought by Red Hat. But before then, I left to go to work at Google Cloud because I felt like all the technologies at the time I was so interested in. There was this natural relationship. Sure. I love Golang. I was a big fan of all the white papers. I was contributing to Kubernetes. And just like that move from financial services to Puppet Labs, it felt like that jump again because I was already working in the space and man, was cloud taking off.
And you applied at Google or you were hired by Google?
Yeah, it was more of a recruitment process. So I've been there 7 years and I actually was going to go take a different job. I was going to go work at NASA in Pasadena at JPL because they were starting to use a lot of these tools. So that's where I was going to go after CoreOS. But the recruitment process was great. The offer was great. And so I ended up going to Google. And honestly, the alignment, and I'm glad I made that decision because I've been there 7 years now and I've been able to leverage all of my skills that I've accumulated over the years. And in this case, turning open source projects into actual products was perfect for what the cloud is all about.
I think for you, if you like Kubernetes, I mean, the only place you can go is Google, right? I mean, because Kubernetes was started at Google with the Borg system.
Well, you could have went to Red Hat.
Yeah.
Because Red Hat was a huge contributor at the time.
Yeah.
You could have went to VMware because VMware was already starting to.
But Red Hat was always number two, was never number one. I think Google was always number one, right?
Well, it depends on how you want to do it, right? Because remember, Red Hat had the enterprise market.
OpenShift, right?
Before OpenShift, they had all the Linux distros. They had OpenShift.
Yeah.
They had OpenStack. Right? So that for a long time, Red Hat has been involved in open source and turned it into a business. And so I think at the time, it was clear that IBM was going to get involved. It was clear that Oracle was going to try to make a play. And eventually, even when I joined Google, maybe 2-3 years later, Brendan Burns, one of the original founders of Kubernetes, he went to Azure. Right? So it was clear Azure was going to get involved. So I think you could have went into a lot of different places. But yeah, you're right. There was something about being next to the people I've been working with all of this time in the open source community and just knowing that Google had the right DNA to make sure that Kubernetes will keep evolving.
Yeah. I mean, this is, I like Java and I like Sun, right? So this was, I like Java programming language and Sun. I never worked actually for Sun, but I really liked everything which was Sun related. Just, I don't know why. This is similar to Kubernetes and Google, I would say. What is your job at Google? So at the beginning, so you were...
So when I joined, I ended up going into developer advocacy. I don't know if I've ever did advocacy the right way. Because as someone who was contributing
the hard way, at least, right?
Yeah, I think I did it the hard way. I mean, for me, advocacy was enabled to just kind of focus on some of the related work. So there's the write the code work. There's the fix the bugs work. But there's also the what should it be work. And if you think about it, most engineers have a little bit of advocacy that they have to do. For example, if you wrote a library or a framework, you got to get other people to use it. How do you get them to use it? Sometimes you're going to write docs. Sometimes you take feedback. Sometimes you evolve the API. You refactor the API. So there's a lot of that work going on. But at cloud, in addition to that, you have to actually bring these products to market. And so if you want adoption at the cloud level, then you have to go in and say, listen, why can't you use Kubernetes? And you'll get a long list of issues from various companies. So my role was to take those issues and say, hey, we should reprioritize the roadmap this way. And so I'm still writing prototypes. I'm still contributing a little bit. I'm also contributing to other projects like Open Policy Agent. There's a lot of things going on in the world. And so you still go in there and you kind of do those things, but the role changed. I started working a lot more with customers, right? These big enterprises are new. You're the person who wrote the book. You're the person, they remember you from CompD. They remember when you used to work at Puppet, so they trust you. And so when you come in, you say, hey, listen, Kubernetes is not going to solve all your problems. It's really good at these problems, and here's the big picture. So I did that for several years. During that time, Google open sourced new projects, and I helped those go to market as well and built various prototypes to make sure that they integrated with the existing ecosystem. Istio comes to mind, right? When we're trying to do networking and service mesh. These days, my official title, I'm a distinguished engineer. I'm not in developer relations anymore.
Okay.
And so, but the thing is, the job is very similar. Like today, we just open sourced a new framework for writing applications called Service Weaver, like just hours ago.
Okay.
And that team at Google is a bunch of engineers who were like, hey, we need a framework that helps people write apps in one of the ways that in way Google writes apps. So we start with very modular code, typically in a monorepo, and you just write the code as you normally would. And at runtime, the framework can actually split that into microservices and deploy it to a target architecture like Kubernetes as an example. And so what we want to do is say, instead of thinking about gRPC, instead of thinking about how to communicate with all these services, write your code like you normally would, and let Service Weaver break them up, stitch them back together, handle observability, metrics monitoring, and maybe just work at a different versioning model than what we're used to. And so that's launched today, and people are going to kick the tires, and then we're going to have to figure out, is this something that's going to work in the real world? Do developers really want to use a framework like this to write their applications? And if not, our goal is to make that framework better until it does.
Okay. Interesting. So I would have to invite you back to just to talk about the framework. Sounds really interesting. But why I invited you? Because you are the Kubernetes guy, and my observation is the following, and you can interrupt me and correct me at any time. So Google open source, Kubernetes, and Kubernetes because developers like Google became very, very popular, and Google, Kubernetes is Google is home of Kubernetes, I would say, right? If you run on GCP, I would say Kubernetes is really well integrated to the GCP cloud platform. So what happened then? AWS and Azure saw, Kubernetes is everyone would like to have Kubernetes, and we can also do Kubernetes. The problem the other cloud providers have is they have, they had ECS Fargate, for instance, Azure App Service. There are services which were already existing, so they had their own easy-to-use container orchestrators. And I like them a lot. So Fargate is great, so I can just start, I have that much JSON, 10 lines of JSON, and I can just start, my Docker containers. But then my clients sometimes say, okay, but we would like to have Kubernetes on AWS. And then the problem starts. So what I get there is like, Spring inside Whitefly, right? So I get now cloud in a cloud. And I say, why are you doing this? Because I have to, now I have Kubernetes is complete cloud. AWS is complete cloud. And now I have, to maintain my IAM users and Kubernetes users, keep them in sync. I have to start with CDK and AWS and then, switch to CDK for Kubernetes. And this is just craziness on earth. So why you would like to have Kubernetes at all? For me, it doesn't make any sense. But if I go to Google, and for me, the Kubernetes is just a container orchestration service by Google. It happens to be Kubernetes. I don't care. I just like to ship the application. This is basically it. So, and I wanted to know, is this the right observation that, Kubernetes on premise is the way to go? I mean, you cannot just run multiple containers with Docker Compose in one point of time. I mean, you cannot, maintain the ports well enough. So you have to have something like Kubernetes. I would say the best would be not run plain Kubernetes, pick a distribution, OpenShift Rancher to get the patches, because your time should be spent, with business logic and not maintaining Kubernetes. But on cloud providers where they have own orchestration and Docker orchestration solution, Kubernetes is maybe not that appealing, I would say.
Well, so think about how you make your own technology decisions today. You typically don't wait till you pick a cloud provider before you start using the framework. You pick a framework that works for you, right? You're in your local laptop, you download a framework, maybe you pick the one that everyone else is using, the best support, you heard good things about it, or you used it before. So there's something about familiarity, like you've been using Java for a very long time. My guess is and you have your preferred frameworks. And so if you want to do something and it doesn't work locally, I'm pretty sure you're not going to probably use it. You're like, no. If I need to test it locally first, like even just on your laptop.
Yeah.
So if you think about the way people think about platforms, when cloud first started, what did it do? It used the most familiar thing, which was a VM from the days of VMware, lots of on-prem ideas, and the cloud just gave APIs to automate and manage that stuff. And then we get the parallel movement with things like Heroku, right? Where we say, let's just focus on the app. As a cloud provider, though, you have a problem. Just like we have in the programming world. In the programming world, we have the standard library. And depending on how big your standard library is, like this is all people need. We have JSON, we have XML, we have HTTP server. What else do you need? People's like, we don't want to do HTML. We want to do gRPC, or we want to do raw TCP. And so eventually the standard library either gets bigger or third parties spin off another framework, and then people have to combine it with the standard library. And there's the friction. Because if the open source framework doesn't stay in tune with the standard library, bad things can happen. Okay? Cloud is very similar. Cloud, we started with just very basic IaaS, load balancer, storage, VMs, and we're finished. You start getting tens and tens of thousands of customers. This company wants a different abstraction. Which one do they want? They want the one they like. So even if you have your own, because remember, before Kubernetes, we had App Engine, right? We had waited.
Still around.
Yeah, still around. And so, but Kubernetes is popular. It has a really nice workload API. The community is growing. It eliminates a lot of external tools. So instead of just using VMs with Puppet, Chef, Ansible, Terraform, Kubernetes is like, look, just focus on describing the app deployment, and we will take care of the rest of the stuff. And a lot of people looked at that on-prem. If you're in infrastructure world, you probably tried it on your laptop with Minikube, and you said, wow, this is an evolution on the way we manage services today. Now it's time to go to the cloud. What are you going to ask for? Just like you as a developer, you're going to say, hey, I know you have ECS. I know you have Lambda, but my app, my knowledge works good on Kubernetes. I would like to see Kubernetes. And let's be fair, Kubernetes actually did some things that ECS on Amazon did not do, like having pods, multiple applications, describing the health checks, volume management. So there were some features that you could only get when using Kubernetes. So of course, those other things have closed the gap in some ways, no problem. But I think this is why you start to see this momentum. And once you kind of get this momentum, when other people say, hey, I want to go to the cloud, how would you manage your distributed system? I don't know. I've used Kubernetes. So now all of the knowledge, all the conversation starts to rally behind Kubernetes. The same was true of Linux. Why not just use FreeBSD? Why not use Solaris? Why not use AIX? I think once Linux came out, Linux became more accessible. You can just run it locally. And if you got your skills with Linux, you want it in the cloud as well. So I think that's what happened. Is it was more of an evolution. And as a cloud provider, you're in the business of providing services. So if people don't like ECS, then and they want Kubernetes and they're willing to pay for it, then you're going to add Kubernetes as an option.
What I meant is something different. So for me, on AWS, I would pick. I will pick ECS Fargate, for instance. And if I really would like to have Kubernetes, I will go to Google Cloud. Because the reason is, what I meant is because in Google Cloud, Kubernetes is managed native service. It is, without paying for the control plane, it is already there. But if I go to different cloud, I have, to set up my own Kubernetes.
Well, look, and Azure is pretty good too. I'm going to be fair. In Azure, Kubernetes is pretty integrated. I would agree. AWS is not as good. But why are people still doing it? They're still doing it because sometimes they're just forced to run in AWS.
Exactly.
And they still like the Kubernetes abstraction. And so to them, it is cheaper mentally for them to deal with getting Kubernetes on par, at least enough of it, so that they can keep using their workflow that they use on GCP as well.
My observation is from, Java world is often, people say cloud native, then Kubernetes. And the architects say, okay, now you developer, you have to run Kubernetes, and they have no choice. But developers actually only would like to have Docker, at least in the Java world. They don't think that far that, we have clusters, whatever. They've write as Docker and they are done. And who starts the Docker containers? They don't care. So if you go to Google, you get very good experience. And I wouldn't just pick Kubernetes because I have nothing to do. I ship, my Docker files and they are running. So it's really nice experience. But I'm not absolutely not interested in my projects to run my own Kubernetes cluster, watch the patches and patch the worker nodes. This is for me is like Java. It is worse. I don't know whether you remember with JBoss. Remember the tool called Xdoclet? You remember this? Xdoclet, which generated lots of XML deployment descriptors for JBoss, huge XML files. So this is in some projects, this is my Kubernetes experience, huge Helm charts, whatever. It's like, what are you doing? Just focus on your business logic.
I agree with you 100%. Kubernetes was never supposed to leak.
Exactly.
To the developer.
Exactly.
I agree 100%.
Exactly.
Kubernetes is an infrastructure SDK. It's an infrastructure framework.
Exactly.
And so for a developer, and I've given a keynote like this at KubeCon one time. I said, listen, a developer writes their code. They're going to give you a manifest that says, here's my package.
Yeah.
I need networking. I need to talk to my dependencies. If you know that, why are you asking me again?
Exactly.
Right? And so when you go to like Heroku, there's an easy way to kind of describe that. If you use Cloud Run, easy way to describe that.
Yeah.
I think what happens in the Kubernetes case, there are some things that look easy, like a basic deployment file. It looks easy. But then it starts to leak when the team says, oh, you have to set up your own autoscaler. So you're like, how do I do that? Oh, you have to create another Kubernetes file. Yeah. It's like, you know what? You also need to run this Helm chart. It's like, oh my God, stop.
Yeah.
Now we're going too far. And
exactly.
I agree with you. I think Kubernetes and some implementations leak too many of the details that become super frustrating.
Or it's completely misunderstood by Java developers, at least. This is my world, They love the Helm charts and they just write, huge Helm charts. Okay, look, this is even worse what we had with application servers back then. The Helm charts is longer than actually the Java files, so forget about that.
You know what? That was a common problem because I remember when I used to support and when I was learning Java, the number of Java developers that didn't know anything about the operating system. They didn't know what a file descriptor was. They didn't know anything about inodes.
Yeah.
They didn't know what to do when the init system would crash and take their application with them. They're just like, look, I just write to the JVM.
Yeah.
The JVM works out the differences between the operating systems. Why are you telling me about inodes? And I was like, well, there's real inodes and you've ran out of them and your app is not going to work. And so I get it. So we want those abstractions. So you're right. There's a need for that. So you're right. Layers are required and we got to just make sure we don't leak. But look, it sounds like you're giving a lot of compliments to GKE. So we're going to take that.
Absolutely, this is my. I don't care, if you run if Kubernetes doesn't leak to me, I like it, but I'm not interested, or developers should be not interested in maintaining Kubernetes, and this is what happens in lots of projects without a reason. Maybe last question. You wrote a nice tweet about microservices, and we are absolutely, this is my opinion. So this is the next problem I see in Java projects. So I'm a little bit, Java Java heavy because this is what I see in my projects. A few years ago, it was like, if you would like to have a cloud native application, you have to write, hundreds of services, microservices called, and they communicate via, HTTP. And I asked why, and there was no answer. So the answer was because we have to be modular, whatever. It's like, I don't care why. And they tried to explain that if something is simpler, nothing was simpler. I'm really glad that people like you say now monolith is absolutely perfect. And this is also what I said in my architectures. Just start with a monolith. And if you have a problem, several teams or whatever, then we can split the monolith. But I will never start with microservices. I don't know whether this is also your opinion, but what's your take on it?
Yeah, I mean, I've always learned that you should always write modular code.
Yeah.
Always. Like when I learned Bash, there was a binary for sed, there was a binary for awk, and they were their own world. And if you ever wanted to use them together, they had inputs and outputs. So if I load them in my Bash script, I will be just going through standard in, standard out. And so in my world, is that microservices? Not really. It's just modular code. And at deploy time, my Bash script would, in some ways, embed them.
Yeah.
Right? Straightforward.
Yeah.
And so when I got into the Java world, I think most of the stuff was monoliths. But I also remember you don't have to have just one monolith. You can have a monolith that handles all the different payments integrations, but then you may have a different monolith that handles the web front end stuff.
Exactly.
That is fine. You can have multiple monoliths. I think the thing that went crazy for people was a lot of people didn't have the discipline to write code in a shared code base, right? Especially when you start doing object-oriented stuff, when people start reaching and modifying, you start creating spaghetti code.
Yeah.
To me, that was always a lack of discipline. So I think some people went to the extreme and said, hey, I'm just going to start over, get my own repository, maybe even copy and paste that code, but I know you can never violate my contract because now it's with HTTP, not with the source code. And so I can see value in people saying it's an extreme measure of decoupling. Yeah. It's a very extreme measure. And I think in the cases where you're a different company, that's the default. We all write different stuff in different languages, but we don't call that microservices. So I think the microservices architecture, it got oversold, and I think it was trying to solve a problem that had more to do with discipline than technical challenges. So I kind of respect both paradigms, but I'm with you. If you write modular code, then you can pick whether it's microservices or a monolith or a mixture of each of them. It shouldn't matter as much. So you're right. Starting with microservices day one, it tells me that you're probably going to make a big mess and you're going to build just a distributed monolith versus focusing on the app domain and making sure that the code is modular. We can decide how we import those modules later.
Exactly. I got lots of contracts, to companies called me and say, help us with microservices. We have a monolith and they would like, to have microservices. I asked them why. And this was exactly what he said, because they don't understand their own code. So, okay, so let's try to remove all interfaces, all impulse, all factories, all configurators, XML, and if you delete everything, what remains is the business logic. And then you're almost done. Then you understood what happened in your code, and then you can say, okay, now my monolith, I can maybe split what, as you said, in two monoliths, but then we are done. So I would say, the microservice term is a little bit harmful even, right? Because it sounds like a best practice, and it's just a solution to very particular problem.
Yeah, and I think it also, there's a situation where you have the nice monolith, but I remember when we used to integrate with something new, and let's say Java didn't have great libraries, and we didn't want to write new libraries, I can see why people would say, hey, we have to go write this in a different service using that other programming language. So we can get the integration done, and then we're going to have to communicate via a common protocol like HTTP because we have no way of doing it in memory. Okay, that makes sense. Maybe you have to do this for expediency, but as a default pattern that you should do no matter what.
Yeah. Okay, cool. Maybe last question, a very last question. Do you like Rust?
I tried Rust, and it leaks a lot of details that I don't want anything to do with, right? The way you talked about Kubernetes leaking details. Yeah. At this point, the type of software that I'm trying to create, I don't mind the Go runtime memory management overhead. I need the simplicity. And so when I'm trying to learn Rust, look, I'm like trying to study the language and memory management, and it's too many concepts that I think you get into too early. Borrowing and this thing and pattern matching, and it's like amazing language features, don't get me wrong. But it's too much for what I'm trying to do. So I look at it, I think I know why people are excited, but for what I'm building, I'm going to stick with Go for now and be happy.
I thought, because you maybe already contributing to Rust, this was my...
No, I've learned that it's just as important to learn what to ignore. And focus requires ignoring some really great things. And I think Rust is one of those things that is probably great, but I have so many things on my plate, there's no way I can get that deep into Rust right now.
Why you wrote Kubernetes the hard way, the repository on GitHub? You did it at Google? Was it your idea or?
Yeah. So here's the thing. As someone who worked at the core of Kubernetes, I understood the code base really well. I knew where various integrations were happening. I could debug things. I even knew the code path that it was going down, and so I knew how Kubernetes fit together all together. And in the early days, everyone kept saying Kubernetes is complex. And in my mind, looking back at my career, what's complex? Linux, Bash, Puppet, Chef, Ansible, Terraform, JVM, JBoss. You got to put all this stuff together to do anything. And I think a lot of people have learned those stuff over decades. And so they just have muscle memory. So they think it's easy, but it's not. And so I said, why are people saying Kubernetes is hard? it's not the API. It's not YAML files. That's not why. I think it's hard because people doesn't know how it works. And so I kind of make this deal when I joined Google. I said, listen, we can write all the docs. We can make all the videos. What people want, they don't want a script. They don't want a one command create the cluster because you have to debug it in production and you don't know what to debug. So I'm going to write a guide that goes step by step, even the boring details like generating SSL certificates. I need people to see these things.
They are particularly useful. Certificates, everyone hates them. Yeah.
Yeah, exactly.
Yeah.
But I make people see the whole thing.
Yeah.
And what I learned was the people who have to manage the cluster or understand what's going on, they like to go through the exercise just so they feel like, oh, I get all the moving parts. I know exactly how they fit together. It's no longer managed or magic. And I have to make two choices now that you're done going through the whole guide. If you want to run it yourself, this is what you're signing up for.
Exactly.
If you don't want to run it yourself, then you should go and use a managed service because just like building a Linux distribution from scratch, why would you want to do that all the time? It makes very little sense when you have all of these distributions. But if you want to know how, then the guide is for you.
Exactly. And you are working for Google, so it's an unfair question, but I think still Kubernetes on Google is the best developer experience right now, right?
Yeah, I would say so. And I think it's because we're all in. It's the only container service we have. So I think you made a good point. You know, there's Fargate, there's ECS for Fargate, there's Kubernetes, EKS, App Run. When you start having all of those, my guess is you have to spread out the UX decisions across them all.
Exactly.
And in Google, we say, listen, anything that GCE can do, we try to really quickly make it available inside of Kubernetes. And since Kubernetes has this big bet for us, we've actually changed the way GCP works in order to support Kubernetes. That's why it feels so integrated. And also we get a lot of feedback that, hey, Kubernetes is hard to use. So we made things like autopilot that makes it more like Fargate and even less Kubernetes. Like you can't even see the cluster machines anymore. We create them for you on the background. And of course we have serverless, which is Cloud Run, but Cloud Run is also based on a Knative extension or a Kubernetes extension called Knative. So you're right. We've been very consistent in our container strategy to try to get as much leverage from the Kubernetes model with different levels of management focused on user experience.
But something like Cloud Run, in my eyes, only makes sense on GCP because what you said right now, I assume we have lots of machines running behind the scenes and the hyperscaler, right? And the Kubernetes runs across all the machines. So if you have
Cloud Run, there is no Kubernetes.
Yeah, but you have the machines. So it means...
Yeah. So we still have the machine. So it's really more about developer productivity, right? Because one thing we learned in the Kubernetes space, in Kubernetes, you have to install the cluster on top of the machines.
Exactly.
And then you get the Kubernetes API.
Exactly.
Well, with Cloud Run, we're starting more from the App Engine place.
Yeah.
And say, we already have the machines, and we can either give you a VM on top of our machines, we can give you Kubernetes on top of those machines on top of our machines, or we can collapse the two layers and just give you your Kubernetes-like definition on top of our Borg infrastructure without the machines in the middle.
Yeah.
And so now there's only one level of indirection in that case. But thanks to Kubernetes, we now know what API we need from you, the developer, in order to do that.
Yeah, but Cloud Run runs on top of Kubernetes without...
No.
Okay.
I'm telling you, there is no Kubernetes anywhere, not even internal Kubernetes.
Okay, I think...
It literally runs on similar infrastructure as App Engine, right? So we
then
take your
Borg,
container...
right? This is the internal Borg.
In Borg,
right?
Okay, so if, just the behind the scenes, a VM runs as a container on Borg.
Okay.
Kubernetes runs as an installation on top of VMs that are on top of Borg. Okay. And then Cloud Run is like a different stack.
Okay.
Cloud Run just runs on Borg.
Okay, cool. Yeah, pretty cool. So we cover lots of ground, and I'm really glad that I had you because, so my observation is right. You are a sportsman, actually, right? So your approach to IT is like sports. It's fun if you learn stuff. And if you see something interesting, so go for it and try it, right?
100%. I'm a human before I'm an engineer. And so I try to bring humanity to the engineering.
Perfect. Where people can find you?
Twitter. That's the only place I'm using these days. So at Kelsey Hightower. And I like to talk and learn about stuff related to tech and maybe real life stuff too.
Yeah, if the listeners have 5 minutes left, they can try Kubernetes the hard way, right? And they see how much fun is it to run Kubernetes without Google on their machines, right?
100%.
Thank you a lot.
Awesome. Thanks for having me.